Today we are going to be talking about improper rational expressions. For the past few days, we've been talking about rational expressions, which are those polynomials that are put into fractions. So, in order to set the stage and have a strategy for dealing with these, let's think back to elementary school. Your teacher might give you a problem or a fraction like 3 over 5 and say, is this proper or is this improper? What do you think it is? Well, this is a proper fraction. But how do you know? If you look at your numbers, it's smaller on top. If a fraction is smaller on top, that makes it a proper fraction. If you were given something like 9 over 5, is that proper or improper? This one is improper. Why is that? It's improper because it's smaller on the bottom. If you had an improper fraction, your teacher wouldn't just let you leave it like that. They would make you rewrite it as a mixed number. So how did you get that mixed number? You would take that 9 and figure out how many 5s go into it. You would say 9 divided by 5, and you'd say, okay, I've got one whole number, and there would be 4 out of 5 left over. I'm going to put a plus sign here. I know that's kind of weird. You would normally just write 1 4/5, but that plus sign is going to help us later. This is proper now because 1 is just an integer, and if we look at the fraction 4/5, that's a proper fraction. So we are going to use that strategy today to determine whether fractions are proper and improper, and then we're going to look at some examples of if they are improper, how do we make them proper? So we're going to do 5 examples today, and then there's going to be an honors challenge for those of you in honors. If you're not, you can just skip it. So for rational expressions, we're not just going to look at the numbers like we do with the fractions. For rational expressions, we look at the degrees of the numerator and the denominator. So we look at the degree. Remember, degree is that fancy math term for the largest exponent in an expression. If the degree of the numerator, I'm abbreviating a little here, is less than the degree of the denominator, the fraction is proper. So we are going to look at 3 examples of just saying, is this proper or improper? All right, here we go. Example 1. Oops. X over x cubed plus 1. Is this proper or improper? Well, let's look at the degrees. We're going to look at the exponent of the top and the bottom, the largest one. So here we've got a 1 there. So this has a degree of 1. And then here we have a 3 down here. So this has a degree of 3. Think back to elementary school. If you had 1 over 3, would that be proper? Yeah. So this is proper too, because it's smaller on top. We wrote that if the numerator is less than the denominator, we have a proper fraction on our hands. So that's example 1 already done. Our degree is smaller on top. Let's look at example 2. What if we have x to the 4th plus x squared all over x plus 1, x plus 2? Okay, let's look at the degree of the numerator. It's 4. And the degree of the denominator. Now this one's a little bit tricky because so far we've been looking at expressions in standard form. This is actually in factored form. The good news is we know how to rewrite this by multiplying it together. We don't even care about the whole thing. We just need the biggest exponent. So think about if we did x times x, what would that give us? X squared. So the degree of this is 2. Then you could do the rest. I'm going to do it just so you can see it. So plus 3x plus 2 But again, we just care about the degrees. If it's bigger on top, it's improper. All right, let's try a third one. This one's a little tricky. If you were given 4x cubed minus 3 over 5x cubed plus 1, is that proper or is it improper? Well, we have a degree of 3 on top and a degree of 3 on the bottom. What happens when they're the same? Do you think this is proper or improper? There's two ways to think about it. The first way is if the degree of the numerator is smaller than the denominator. Is our numerator here smaller than the denominator? Is 3 less than 3? No, that's not true. 3 is equal to 3, but our numerator has to be less than. So this is improper. Another way to think about it is if you were given a fraction, 3 over 3, would that be fully simplified? No way, that reduces to 1. So however you want to think about it, the numerator has to be smaller. It can't be equal, it has to be smaller. So this is improper. So we have looked at 3 examples of rational expressions, and we ask ourselves, are they proper or are they improper? And we figured it out by looking at their degrees. Now let's look at simplifying. If we're given an improper fraction, how do we simplify it? So let's simplify this improper fraction. 2x cubed minus 3x squared minus x plus 17 all over 2x plus 3. This is an improper fraction. We know this because it has a degree of 3 on top and a degree of 1 on the bottom. So what do? Well, remember how when we looked at our elementary school example, we did some division and then we had our quotient with our proper remainder? We're going to do the same thing here. We are going to divide and we will have a quotient with a proper remainder. Here's the good news. You've done this before. Last unit, you divided fractions constantly. And so we're going to do the same thing. I'm sorry, I think I said divided fractions. I meant divided polynomials. So that's what we're going to do here. We're going to do some division, and we're going to figure out what that quotient is. The nice thing about this quotient is it's going to be proper. So let's do it. We're dividing by 2x plus 3. And if you want to take off without me, feel free because you've been doing this like crazy. So we're going to put 2x cubed in the first blank. We'll have 2x, whoops, nope, we will not. We will have x squared up top. And then 3x squared. We'll look at our diagonal. We want negative 3x squared, so we'll do minus 6x squared. Above that, we'll have minus 3x. And then minus 9x. Our new goal is a negative 1x, so negative 9 plus positive 8x. And then we will have plus 4 up here, and then 12. And our next goal is 17, so we will have a 5 here. So plus 5 over 2x plus 3. So our quotient is x squared minus 3x plus 4 plus 5 over 2x plus 3. And you might be saying, we've already done this before, and you're exactly right. But not in this context. We started with an improper fraction. But look at what we have now. We have our quotient and then a fraction at the end. And if we look at this fraction, it's proper. The degree of the numerator, I wrote it a little slanty, but the degree of the numerator is 0. There's not even a variable there to have an exponent in the first place. And the degree of the denominator is 1. And 0 over 1 is proper. Remember, we said that numerator needs to be smaller. So you are using your old skill of dividing polynomials to make an improper fraction into a proper expression. So now this answer is proper, and we are happy. Let's do one more example, and then that honors challenge is coming at you. So we are going to simplify x cubed minus 6x squared plus 28 all over x minus 4. So again, this is improper. It's a degree of 3 over degree of 1. We can't leave it like that. The good news is we have the skills to get it where we need it to go. Now, there is something tricky about this, so I encourage you to pause the video and look for a second about an adjustment you may need to make before you start working through this problem. All right, you should have found that right here, there's a missing x term. So you want to rewrite the problem x cubed minus 6x squared plus 0x plus 28. That changes things because now your exponents count down by 1, all divided by x minus 4. So if you miss that placeholder 0, remember that skill as you go through this problem. So we're dividing by x minus 4. Trying to change the color to purple and it's not letting me, so we might just have to rock with green for a while. All right, so we are going to have x cubed up here, x squared minus 4x squared. Our next goal is negative 6x squared, so minus 2x squared minus 2x, positive 8x. Our next goal is 0x. So remember, we're trying to get to this 0x, so minus 8x. And then above, we will have minus 8 and positive 32. And then we're trying to get to 28. So we'll have minus 4, so minus 4 over x minus 4. So again, you've done this skill, you've used this skill before, but what's different is the context. You started with an improper fraction, but if you look at this, you've got your quotient and then this fraction at the end, that's proper, and we're happy. All right. So if you're in honors and you're up for a challenge, here it comes. Either way, you should do your classwork and make sure to do your homework, whether you're doing this honors challenge or not. So here comes an improper fraction that you'll need to simplify. Sorry, that's a 5. My 5s look rough. There we go. All over x squared minus 3x plus 2. So you have done problems like this before. Again, the context is new. This is a challenge. This time you are required to have a box height of 3. So I encourage you to pause the video here and try this problem on your own. It's a challenge. If it's hard, that's okay. It's supposed to be tough. That's what makes it a challenge. All right, so I'm going to work through this problem for you so you can check your work as you go along. Let's see how it goes. You know what? I'm going to write the answer here, and that way you don't have to wait for me to check, but then I'm still going to work it out. So if you want to see it worked out, you can. All right, so there's the answer. That's your goal, and it's a proper fraction, so it should make you happy. All right, here comes the work. X squared up top, minus 3x cubed, 2x squared. All right, our next goal is negative 7x squared. So we got x to the 4th, negative 7x cubed, my bad. So we have a negative 3 on the board. We'll have a negative 4x cubed. We'll go along the top, minus 4x, positive 12x squared, minus 8x. All right, our next goal is 15x squared, and this is where most students make a mistake. They see that they have a 12x squared on the board, which is great, but they forget that there's also a 2x squared on the board. So we currently are looking at 14x squared on our box already, so we only need one more x squared to get to 15. So if you put 3x squared right here, know that's a very common mistake, but you've got to look at your whole diagonal. Otherwise, it's no good. So this should just be regular x squared, or 1x squared. All right, let's go across the top. All right, our next goal is negative 11x. So let's check these. Yep, these add to negative 11x, so we don't need anything here. And then let's check our next goal is plus 5. We have a 2 on the map, so we need a 3 to bring it home. So that's our remainder. So there is your honors challenge. Again, please make sure to do your classwork and your homework. Thanks so much.